So this is problem 1 of the review problems, which asks us for each of these situations whether Q is proportional to T. So this first one, 1A, this is our basic relationship of proportionality. It's as simple as Q is some constant, the constant of proportionality, times T, times T. So yes, these are proportional. If you want to check, you can pick some simple value for T, like 1, when T is equal to 1. Q is 0.085. And what happens when you double T from 1 to 2? Well, if T doubles from 1 to 2, then when you plug 2 into this, you get I will double check. You get 0.17, which is indeed twice 0.085. Excuse me, so that's times 2. So yes, these are proportional. B is a very simple relationship, but here this plus 0.5 is sufficient to mean no, it's not proportional. All it has to do is be this little bit more complicated. And again, if you're not sure, try plugging in some values for T and see what you get for Q. If you plug T is equal to 1, you will get 0.585. Whereas if you, let's try tripling T. If you multiply T by some amount, if you triple T, then Q becomes, I just typed the wrong thing into my calculator. If you triple T, then Q becomes 0.755. So T tripled, Q did not triple. Why did I pick tripling for B and doubling for A? It doesn't matter. What I have to say is if it's proportional, if I multiply T by any number, 2 or 3 or 10 or 17, I have to multiply Q by exactly the same number. And if that doesn't happen, then they are not proportional relationships. In C, again, I'm looking at this simple relationship. C stands for some number. It might be 12, it might be pi, it might be 72, but whatever it is enough to say that this is not a proportional relationship. Technically, if C is equal to 0, it would be proportional, but that's not something I would ask you to say. How about D? D is fairly simple. It doesn't have a plus anything, but it does have this squared. So if you get a little bit confused, you know at this point how to check it. Pick a value for T and see what the resulting value for Q is. I don't always have to start at 1. Let's start at, at 10. If T is equal to 10, Q is 10 squared over pi, or 100 over pi. And if you wanted, you could get your calculator to turn that into an actual number. It's roughly 31.8. But if I double T to 20, then Q would become 20 squared over pi, or 400 over pi. And just looking at this, 400 over pi is not twice 100 over pi. The actual value is something like 127.4. Oops, wrong color. So this does not double. So just to be sure, no, these are not proportional. You didn't have to do all that work. That squared there was enough to say, this is weird. These are not proportional. How about E over here? E, I've got the square root of 3, and that might be a little disconcerting, but that's just a number. This is Q is equal to T times some number. The number happens to be the square root of 3 instead of 0.085. Yes, these are proportional, and this square root of 3, that is my constant of proportionality. So as long as my relationship is Q is some number times T, they are proportional. Now let's look at F. F, we have words instead of numbers. So I'm looking at T days of a car rental, and the cost is Q. This is my daily cost to rent the car, but in addition to having to pay each day, I also have to pay a fixed amount for insurance. I have to pay an extra $20 for insurance, no matter how long I'm renting the car for. So that means that Q is equal to, I have to pay this $39.99 for every day that I'm renting a car, and then I have to pay an additional fixed $20. So is that proportional? Nope. That piece right there is the part that makes it complicated. It is not proportional. And I could actually see that just looking at this description. The description has a rate part and then something else. And that something else is enough to make it not proportional. How about this last one? Q is a cost to drive T miles. I have a cost of gas. I have a mileage. I've got to try to figure out what's going on here. So how much does it cost to drive T miles? Oops. Well, can I figure out the cost per mile? Oops. From all of this information? Well, I have a distance. I know that my car gets 20 miles on 1 gallon of gas, and I know that 1 gallon of gas costs $1.49. So for the cost of $1.49, that's 1 gallon, I can go 20 miles. So this tells me, so the cost per mile would be equal to $1.49 divided by, because per means divided by 20 miles. That calculation would tell me the cost to go 1 mile, because I was taking my $1.49 and breaking it up across 20 miles. If I do that, I get 7.5 cents, 0.0745, I'll round that to 0.075 dollars per mile. So I can figure out the cost to go a mile, and it's this simple sort of rate relationship. So that says the cost to drive T miles is take the number of miles, and every one of them costs me about 7 cents. So if I take that 0.75 cents per mile times the number of miles, I am going to get the cost to drive T miles. Is this one of our proportional relationships? Yes, it is. It's very simple. It can be described purely in terms of a rate, and that right there, that's my constant of proportionality. So that is how we tell whether something is proportional or not. And if you're a little confused by this, I suggest you go back and watch the video, I think it's video 2A or B, from our second day of class.